Welcome back to this lecture on recursive algorithms. In the next segment, we're going to study a famous recursive sorting algorithm called merge sort. But before we get to that, in this segment, we're going to describe an algorithm called merge that is a helper function for the merge sort algorithm. So the merge algorithm solves the following problem. Suppose you are given two finite sequences of integers in ascending order. So as a computer scientist, you can think of those as two arrays of integers sorted in ascending order, with the smallest integer at the beginning of the array and the largest integer at the end. The problem is to merge these two sorted arrays or sequences into a single merged sequence that is also in ascending order. So for example, if I give you the sequences 1, 3, 5 and 2, 4, 6, you would return the sorted sequence 1, 2, 3, 4, 5, 6. So here is a pseudocode description of an algorithm to solve this problem. I call this the merge algorithm. So it's a function, since it returns a sequence of integers. I'm going to call it merge, and it takes in two arguments, two sequences, which I'm going to call A sub I and B sub I with a standard notation for sequences. Again, you could think of those as arrays in data structure terms. Now, these are sequences of integers, and the important constraint is that they must already be sorted in ascending order. Now, this algorithm must return a single sequence, that is the merged sequence of both of them, and that sequence must also be in ascending order. So this algorithm is going to build the result sequence incrementally. So we start by initializing this result sequence to the empty sequence. Then it's going to go through a loop, and every time through the loop, it's going to pick the smallest remaining elements in the two sequences. It's going to remove that element from the sequence it belongs to and adds it to the result sequence. So the termination condition for this loop is when one of the two sequences becomes empty. So while the first sequence is not empty and the second sequence is not empty, we keep going. So we're going to look at the first element in the first sequence, let's call it A, and the first element in the second sequence, let's call it B. These are two integers, so we can compare them. And if A is smaller than B, then what do we know? Well, we know that A is the smallest integer in sequence A sub I, since it was the first term, and it's also the smallest element out of all the elements in B sub I, because A is smaller than B, and B is the smallest element in B sub I. So A is the element that we want to add to the result sequence. So we're going to do that. We're going to add A at the end of the sequence called result, and we're going to delete A from A sub I, since we took care of it. Now what happens if A is not greater than B? Is not smaller than B? Well, if A is greater than B, then clearly B, the first term in B sub I, is the smallest element that we want to add to result. So in this case, we're going to add B at the end of result, and we're going to delete it from B sub I. Now notice what happens when A and B are equal. We also go through the else case. So in case of a tie between A and B, then the first element of the second sequence is taken out of it and added to result. So this keeps going until one of the two sequences becomes empty. So when we exit the while loop, one of the sequences is empty, but the other one may not be. So we still have to take care of the remaining elements in the other sequence. And all we need to do is that since the elements are already sorted in the input sequences, we just need to add the remaining elements to result. So we're going to append the remaining elements in A sub I at the end of result and do the same thing for B sub I. Now notice one of these sequences is going to be empty at this point. But since we don't know which one, and it doesn't hurt to append an empty sequence at the end of result, we do it for both. And at the end, we are ready to return result, which is the merged sequence in ascending order. Now let's illustrate the behavior of this algorithm by tracing it on a concrete example. Let's take these two input sequences, 3, 5, 6, 9, 12, and 1, 2, 4, 5, 8. Notice the fact that these two sequences have the same length is a coincidence. This algorithm works whatever the length of the sequences as long as they are finite, and as long as the two sequences are sorted in ascending order. So we have three variables, the result sequence and the two integer variables a and b. Initially, the result sequence is empty, and now we enter the while loop. Since neither one of these sequences is empty, we are going to compare the first element of the first sequence, which is 3, to the first element of the second sequence, which is 1. Since 3 is not less than 1, we're going to execute the else block, which means we're going to add b to the end of the result sequence, and we're going to delete b, which is 1, from this sequence since we just finished processing it. Now we go back to the top of the while loop, and neither sequence is empty, so we look at a, which is still 3, whereas b is now the first new element or term of the sequence, which is 2, and we compare a and b. 3 is not less than 2, so we go through the else block again, and we're going to add b to the end of the result sequence, and we're going to delete it from b sub I. And we go back to the top of the loop. Again, the sequences are not empty, so a is equal to 3 again, b is equal to 4 now. 3 is less than 4, so for the first time we're going to execute the then block. 3 is going to be added to the end of result and deleted from the first sequence. And so on and so forth. I'm going to go a little bit faster now. We're back to the top of the while loop. Neither sequence is empty, so we're going to compare 5 and 4. 5 is not less than 4, so we're going to add 4 to the end of result, and we move it from the second sequence. Again, neither sequence is empty, so we're going to compare 5 to 5. 5 is not less than 5, so we're going to the else block. We're going to take this 5 and add it to the end of result and delete it from the beginning of the second sequence. Neither sequence being empty, we're going to compare 5 to 8. 5 is less than 8. Therefore, we're going to add this 5 to the end of result, and we move it from the first sequence. Neither sequence is empty, so we look at 6 and 8. 6 is less than 8, so we add it to the end of result, and we move it from the first sequence. Neither sequence is empty, so A is now equal to 9, B is still 8. 8 is less than 9, so we go to the else block. We add 8 to the result sequence, and we remove it from the second sequence. Now when we get to the top of the while loop, notice the second sequence is empty. Therefore, this condition is false. We exit the while loop, and we're down to this line. This line says we should append the remaining terms in the first sequence, namely 9 and 12, to result. Then we should append the remaining terms of b sub I to result. There's no such element, so we append the empty sequence. And then we're done. The merged sequence is in result, and we can return it.